Okay, welcome back guys to another video. Today we're going to be doing limits of accuracy. And I'm just going to start off with a quick crash course because you're busy people. And if you don't understand, you can just watch until the end of the video. So let's assume that you're given a ruler and you're told that the ruler has a length of L, which is 30 centimeters to the nearest centimeter. So how do you find the upper bound and lower bound of the length? You're just going to take your 1 centimeter, divide that by 2. That gives you, 0.5 centimeters. Add that to 30 and subtract that to 30 to get your upper and lower bounds. Of course, we're not equal to our upper bound, but we are greater than or equal to our lower bound. If you don't get that, just stick along, right? So L's between 30.5 and 29.5. And we're given that W, our width, is 4.5 to the nearest millimeter. We apply the same thing. 1 millimeter, divide that by 2. Okay, we still get 0.5. And now we add that and subtract that to what we've been given for W, right? Which would mean that W is now either is less than 4.55, right? Because we're dealing with 0.5 millimeters, and is greater than or equal to 4.45. If you want to quickly check if you're correct, that you did the right thing, the difference between these two numbers should be 1 millimeter, or 1 centimeter in this case, or 1 kilogram, or 1 gram, or whatever they gave you. Now, we can be asked to calculate the area that this ruler covers. This somehow it's 30 centimeters to the nearest centimeter, but we're still using it as a ruler. Anyway, the area of this, we can be asked to calculate the largest area. The largest. No, let me not. The largest area. And the smallest area. Of course, now you have to recall the formula for calculating area of a rectangle, which is just length times width, right? So for us to get the largest area, when we're just simply multiplying two numbers, to create the biggest value when we're doing multiplication, it's just to pick the two largest numbers for length and width. So we'll pick 30.5 and 4.55. That would be our largest area. Of course, make sure that this is in centimeters, this is in centimeters. So our largest area will be in centimeters squared. If they gave us like centimeters, meters, you'd have to do the conversion. Sorry about any car noises. 4.55. And conversely, if they asked you for the smallest area, you would simply just take the two smallest numbers, which would be 29.5 times 4.4. Now I'm just trying to, okay, so let's say they give you they'll most likely give you the formula. This isn't, say density is equal to mass over volume, correct? Right. So now they tell you that an object, maybe like a weird rock thing. Yeah, don't ask about that. Its mass is, let's say, 45 kilograms to the nearest kilogram, to 1 kilogram. And then its volume is, let's say, 1 cubic centimeter. I mean, not 1 cubic centimeter, 1 cubic meter. Sorry, 1 cubic meter to the nearest cubic meter. Okay, sure. Let's just clean that up real quick. So what does that mean? We just apply the same things that you already know how to do. So that means the mass is 1 divided by 2. That's 0.5 kilograms. Add, subtract. So at the most, 45.5. And then less than or equal to 44.5 kilograms, right? And then the volume, same thing, which means this is rho, by the way. Sorry, that just crept up into my mind. 1.5 and 0.5 cubic meters, right? Now, if they ask you for the largest density and the smallest density, then you gotta use your brain. You gotta use your. So right now we're taking mass and dividing it by the volume. And what do you know when you're dividing by a big number? When you're dividing by a big number, let's say you're dividing by 1,000,000, at the end you're gonna get a really small number, right? But if you're dividing by a really small number, like let's say you're dividing by a half, what happens? This 2 goes to the top. You're not really dividing, you're multiplying by 2, you're increasing the number. So dividing by small numbers gets you a bigger number overall. Dividing by big numbers gets you a smaller number. So if you want to find the largest density, you would take the largest mass and the smallest volume, right? So then you calculate the density as 45.5 divided by 0.5. And if you wanted to find the smallest density, you take the smallest mass, 44.5, and divide that by the largest volume, because that'll get us the smallest number. Picking the smallest number up top, and you're picking the largest number at the bottom. So you always have to keep that in mind when these kind of questions come. Significant figures. So if I have 0, 4.5, essentially just the rule for significant figures. Forget about zeros at the front. Reach the first non-zero number and then just start counting the digits going to the right. So this would be 2 significant figures. If I gave you 0.00856, this is still, you just ignore all these leading zeros, get here, and then just count the digits going this way. So that's 2 significant figures. Once again, if I give you 5.06 though, yeah, you ignore the leading zeros. They're not here though, but count the first non-zero number and just count the number of digits going this way. So this is the 3 significant figures. If I gave you 0.8065065060500, the same rule applies. Forget about the leading zeros. Get to the first non-zero number and just count the digits. Even though these zeros kind of seem superfluous, right? When it comes to significant figures, there's a reason people write down what they write down. It's not, you have to count 1, 2, 3, 4, 5 significant figures. Crash course. Okay, welcome back, guys. So if you applied my rule that I just said, presumably in the same video because I should be good at editing now, this would be to 3 significant figures because because you skip the leading zeros, you count all the digits after that, 1, 2, 3. But no, that's not how it works. If there's no decimal points in play, you just count the 3, the 8. So that's the 2 significant figures. You don't count that 0 figures, even without the decimal point. But when the decimal point comes into play, actually this should be like 380.0, even that. Now things become significant because the decimal point is in play. We count 1, 2, 3, 4 significant figures. Because why would you mention the decimal point if it wasn't significant? Why would you mention that? And once again, it does continue. If they put more zeros, you just assume they're putting zeros because they have to be significant, right? No one would just randomly start writing zeros. So the more zeros they add, feest is arcane. So 1/3. You plug that into your baby boy calculator, you get 0.333333, and your calculator just stops giving you stuff because 1/3 just goes on forever with these threes. You can't really represent 1/3 using our number system nicely. So it just keeps on going on forever. If you run into a situation where where a pattern just recurs, of course, in mathematical papers or research papers or something, you can't really just fill up the whole page with 0.333. Like, oh no, I got 1/3 as an answer, and now I'm just making sure you know that as a decimal, it's one, and you just fill out your dissertation using that. No, we've come up with like just a form to represent that, and that's just putting a dot at the top of the repeating section of the decimal. So if we had something like, actually, let me just write this down properly, 0.27272727, pop, 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 pop. This would be represented as just 0.27 repeating with a dot over the 2 and the 7 because those are the two things we're repeating. Of course, if we had, more interesting things like 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, then this would just become 0.123, and you get the gist of it. You put the dots over the numbers that are recurring. Simple. I believe you guys can use your calculators, right? So if they gave you like 2/9, 2, 2, 2, da, 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 da. And of course, since the 2 is the thing that's repeating, you can't really write 0.2222 and then put dots over it. It's just like, even though you are correct that the 3 2's repeat each other, but 2 is the same number in this pattern. So you can just simplify that further to just say 0.2 with a dot on top. Okay.